Right now, on this M2 MacBook, I'm running a 70 billion parameter language model, no cloud, no API key, no monthly bill, is generating responses at 40 tokens per second completely offline. And every single byte of data stays on this machine. By the end of this video, you'll have this exact same setup running on your Mac. And you'll understand why local AI isn't just a hobby project anymore. It's becoming the smartest way to build. Most people think you need a massive GPU rig or an expensive cloud subscription to run real AI models. They picture server rooms, $1,000 monthly bills, data centers humming somewhere in Virginia. But here's what's actually happening right now. Apple Silicon Macs, the same laptop you might be watching this on, are quietly becoming one of the best platforms for running AI locally. And almost nobody is talking about how to set it up properly. I've been running local models as part of my production stack for over a year now, building AI automation systems for Canadian businesses. Today, I'm going to show you everything I've learned on what works, what doesn't, and exactly how to get started. Before we touch any further on AnyZai software, you need to understand why this matters beyond the cool factor. There are 4 real reasons to run models locally, and 3 of them have nothing to do with saving money. First, privacy. When you send data to their API, that data leaves your machine. For my clients at Local AI Hub, many of them are handling customer information that falls under PIPEDA, Canada's privacy law. Running a model locally means their data never leaves the building. That's not a feature. That's a compliance requirement. Second, latency. API calls take time. You're waiting for your request to travel to a server, get processed, and come back. A local model on an M series Mac responds in milliseconds. When I'm building automation pipelines, that difference compounds. A workflow that makes 50 model calls goes from 2 minutes to 8 seconds. Third, reliability. Cloud APIs go down. Rate limits exist. Your internet can cut out. A local model runs whether you're on a plane, in a cabin, or your ISP is having a bad day. I've had production systems stall because an API hit its rate limit at 2 a.m. Local models don't have rate limits. Fourth, experimentation. When every API call costs money, you hesitate to experiment. With local models, you can run 1,000 test prompts, fine-tune your system prompts, and iterate without watching a billing dashboard. That freedom changes how you build. Well, here's the hardware reality check. Apple Silicon changed everything for local AI. The M1, M2, M3, and M4 chips all have unified memory architecture. That means your CPU and GPU share the same pool of RAM. This is massive for AI models because the biggest bottleneck is usually moving data between CPU memory and GPU memory. On a Mac, there's no bottleneck. It's all one pool. The most important spec is RAM, not processor speed, not storage. RAM. Here's the rough breakdown. With 8 GB of unified memory, you can run 7 billion parameter models comfortably. That's models like Llama 3.2 8B, Mistral 7B, or Gemma 2 9B. These are genuinely capable. They handle summarization, code generation, classification, and conversation well. With 16 GB, you unlock the 13 billion parameter range and can run quantized versions of larger models. This is the sweet spot for most people. You get access to models that rival what GPT 3.5 could do running entirely on your laptop. With 32 GB or more, you're in serious territory. You can run 34 billion and even quantized 70 billion parameter models. I run a quantized Llama 3.370B on a 36 GB M3 Pro, and it handles complex reasoning tasks that genuinely surprise me. One thing people get wrong, storage matters too, but not for speed. Models range from 4 GB to 40 GB in file size. You just need enough space to store them. An external SSD works fine for model storage since they only need to load into RAM once. The local AI ecosystem has matured fast. There are 3 tools that cover every use case, and you really only need one to get started. Ollama is the one I use most. It's a command line tool that makes running models as simple as typing Ollama run Llama 3.3. It downloads the model, optimizes it for your hardware, and drops you into a chat. But the real power is its API server. Once Ollama is running, it exposes a local API on port 11434 that's compatible with the OpenAI format. That means any tool or script you've built for the OpenAI API can point at your local model instead. I use this constantly in my automation pipelines. I just swapped the base URL from api.openai.com to localhost 1434, and everything works. LM Studio is the graphical option. If you prefer a visual interface, LM Studio gives you a clean app where you can browse models, download them, and chat with them. It also runs a local server, same idea as Ollama, but with a nice UI wrapped around it. Great for people who want to compare models side by side or adjust generation parameters visually. MLX is Apple's own machine learning framework, and it's the performance option. MLX is built specifically for Apple Silicon and squeezes out the best possible speed. The community around MLX community on Hugging Face has converted hundreds of models to the MLX format. If you're doing anything performance critical, batch processing, real-time applications, MLX is worth learning. I use the MLX LM Python package, and the speed difference over standard implementations is noticeable. My recommendation, start with Ollama. It takes 5 minutes to install, and you'll be running your first model in under 10. Let me walk you through exactly what I do on a fresh Mac. This takes about 10 minutes total. Step 1, install Ollama. Open your terminal and run brew install Ollama, or download it from ollama.com. Once installed, run Ollama serve to start the background server. That's it. It's running. Step 2, pull your first model, run Ollama pull Llama 3.3 for the latest Llama model, or Ollama pull Mistral for Mistral 7B if you're on 8 GB RAM. The model downloads once and lives on your machine forever. Step 3, test it, run Ollama run Llama 3.3 and start chatting. Ask it to write a Python function, summarize a paragraph, or explain a concept. Get a feel for what it can do and where it struggles compared to cloud models. Step 4, connect it to your workflow. This is where it gets powerful. Install the Open Web UI project. It gives you a ChatGPT style interface that connects to your local Ollama server. Or if you're a developer, point your code at http://localhost.1434.v1 using the OpenAI Python client. Set the model name to whatever you pulled, and your existing code just works with a local model. Step 5, try specialized models. Ollama has models optimized for specific tasks. Code Ollama for programming, Alava for image understanding. You can feed it screenshots, and it describes what it sees. Nomic embed text for generating embeddings if you're building search or RAG systems. I use embeddings locally for document search and client projects where the data can't leave their network. One tip that saved me a lot of frustration, always check the quantization level. Models come in different precisions: Q4, Q5, Q8, F16. Lower numbers mean smaller files and faster speed, but slightly less accuracy. For most tasks, Q4 or Q5 is perfectly fine. I only use Q8 or higher when I need the model to handle nuanced reasoning. I want to show you how I actually use local models in production, because the gap between cool demo and useful tool is where most people get stuck. Use case 1, content classification. When I'm processing content across multiple brands, I need to route pieces to the right channel. A local Ollama model classifies content by topic, tone, and brand fit in under 200 milliseconds. I don't need Claude or GPT for that. A 7B model handles classification with over 95% accuracy when your prompt is specific. Use case 2, draft generation for iteration. I use local models to generate first drafts that I then refine with more capable cloud models. The local model produces the structure, the outline, the rough copy. Then a single cloud API call polishes it. This cuts my API costs significantly because the expensive model only sees a refined input, not a blank page. Use case 3, development and testing. When I'm building a new AI feature, I iterate against a local model dozens of times before switching to the production model. I test prompt structures, output formats, edge cases all locally. By the time I make my first API call, the prompt is already solid. Use case 4, private document processing for clients who handle sensitive information. I run local models that process their documents without any data leaving their office. Summarization, extraction, Q&A over internal docs, all running on a Mac Mini sitting in their server closet. That Mac Mini costs less than 2 months of cloud API access would have. The pattern here is simple. Local models handle volume, privacy-sensitive work, and iteration. Cloud models handle the tasks that genuinely need frontier intelligence. Using both strategically is the move. Before we wrap up, here are the things I wish someone had told me when I started. Keep your models updated. Run Ollama pull periodically. The community releases improved quantizations and new model versions regularly. A model you tried 6 months ago might perform noticeably better in its latest release. Monitor your memory usage. Open activity monitor and watch the memory pressure gauge while running models. If it turns yellow, you're pushing your hardware. Either use a smaller model or a lower quantization. Build a model library for different tasks. I keep 3 models ready. A small, fast one for classification, a medium one for general text work, and the largest my hardware supports for complex reasoning. Switching between them based on the task is the key to getting real value. And finally, don't compare local models to GPT-4 or Claude and declare them useless. That's like comparing a pocket knife to a chef's kitchen. They serve different purposes. A local 7B model that runs in 50 milliseconds and costs nothing is more valuable than a frontier model for hundreds of real-world tasks. Match the tool to the job. Which use case resonated most with you? Privacy, speed, cost, or something else entirely? Drop it in the comments. And if you want to see a deep dive into building RAG systems with local models, that's coming next week. Subscribe so you don't miss it.